Thank you.
So the first part of the release is the mirroring. So we have a copy of the current one, a part of current one for now, but we have in plan to extend this implementation to a supported database. So first of all, I want to introduce you our agenda, and then we will go in details about the mirroring functionality and configuration and so on. In the first part, I want to introduce the feature, the mirroring. Then we will go on with the configuration part, so the parameter that you need to set inside the parm of the controller, but also the XML that you need to customize under the dynamic workload console, because our release 10.2 is in association with the new version of dynamic workload console 10.2.3. So you need to install the bot part to use the mirroring feature. The communication between the Z part and the Z environment, the controller, server, and the dynamic workload console environment is through the event. So the most important event is the bulk. Thanks to the bulk, you are able to upload the data about job stream, and workstation on the database. After that, you can access this data from a new interface for Z on the dynamic workload console, that is the new orchestration monitor. You can also perform the action from this interface. And another event that is important for the mirroring is the dynamic event. So every change you have done on the current plan will be reflected and uploaded in real time on the database. At the end, we will also take a look to the Swagger. We have two Swagger, one on the Z connector, that is the component inside the dynamic workload console that handle the communication with the Z server, started task, and Z controller. And another one on the federator. The federator is a new component that you will find inside the new version of Dynamic Workload Console 10.2.3. But first of all, what is it, the mirroring? As anticipated, the mirroring is a mirror of the three main objects, job stream, jobs, and workstation, from the current plan to a supported database. This feature is for now available only for Z. The database will be populated thanks to the bulk and dynamic events. So during the current plan construction phase and also during the normal scheduling process. With the new version of Dynamic Workload Console, we have also a new version of REST API, that are REST API version 2. And thanks to this new version, we can reach the aim of the mirroring feature. That is the improvement of performances. This is because the query will no longer be executed on the controller, but directly on the database. The communication between the Z environment and the Dynamic Workload Console environment is via WebSocket protocol instead of HTTP. Okay, in this slide, we can see all the paths followed by mirroring and also all the components involved by this feature. We have the Dynamic Workload Console, the Z connector, and also the new component, that is the federator, that you can see here. And these three components are part of the Dynamic Workload Console package. So you need to install the Dynamic Workload Console package and you will have the three components. The federator and the communication with the database. For Z, we have the Z server started task, the Z controller, and also a new subtask that is the DB filler. Here, DB filler handles the communication and the connection with the federator. Okay. Now we can also see all the paths. These paths are used by the mirroring feature, except for the blue one that starts from dynamic workload console, the connector, the server, and the controller, because this path is used by old monitoring and REST API version 1. But the other are new ones. We will see this path later in detail. Okay, to enable the mirroring feature, you need to customize the parmlib, the controller, and the XML file under the dynamic workload console package. Inside the parmlib of the controller, you need to specify a new statement that is mirror PTS. In the mirror PTS, we have the federator keyword. Inside it, you need to specify host name or IP and part of the federator. The SSL key ring and key ring type for SSL connection. So, for example, the type SAF or USS, and key ring, in this case, the name of the SAF key ring that we are using. The socket timeout. This parameter contains the number of seconds during which the DB filler waits until before the connection with the federator is closed. The engine name, that is an external name for the engine. This name is used by the controller to register itself on the dynamic workload console. Connection factory D, that is the name of the engine that you put inside the connection factory.xml file under the dynamic workload console package. And the secret. The secret is a very important parameter. It is a string, and this string must match the one you specify under the dynamic workload console package in the fed variables.xml file. So the secret keyword in the controllers must match the federator.secret keyword under the console XML file. And it is important for the registration phase when the controller is registered to the federator. Inside the controller, you need also to specify in the OPC PTS statement the code page and time zone. Okay, the first and most important event is the bulk. The bulk follows this flow from the controller with the DB filler subtask through federator and ends on the database. This is useful to have all the data about the three objects uploaded and present inside the DB.
Just one question. The DB filler, is that, did you say, was a subtask on ZSON?
Yeah.
So what's the overhead?
What's
the overhead when we build it?
When we extend the current plan or build the current plan? If it's also writing out to a DB filler.
It depends on the if the current plan is large or not, how many objects do you have inside the current plan. We don't have now performances document about time that we can officially share. So it depends on the structure and of the current plan.
So on the number of operations you have in the plan when you extend it. Obviously, the overhead is proportional to how large is the plan for the bulk phase.
And this is a separate batch job to the actual current plan extend, or is it something that's within the current plan?
It's something that is occurring in the controller, but it's not stopping the execution of the work.
Okay, before the bulk, an important phase is the registration. So the controller secret must match the one on the federator. The controller sent to the federator the secret and other useful information that you have defined inside the mirror PTS statement or OPC PTS statement, like connector factor ID, engine name, time zone, and so on. If the secret of the controller matches the one on the federator generates an authentication token and also an engine ID. The authentication token is stored by the controller for future requests, and the engine ID is a unique identifier for the engine, and we will see later that this engine ID is also useful for performing REST API version 2 on the federator's worker. After the registration, if you go on the dynamic workload console, under the engine connection, you can see the engine coming from the mirroring feature. So in this case, we have distributed engine, ZOS engine defined as an old manner, but also the discovered one that you can identify with this tag discovered. These engines are the one that you are retrieving from the mirroring. In this case, TWSW is the engine name that you have defined inside the mirror PTS statement. If you give the same name for two engines, the federator will append at the end of the second one a random string to distinguish the two controllers. We can see an example, TWSW and TWSW with this particular string at the end. Random is a random and unique. Random is generate random.
You can't change it to something more meaningful.
No.
You don't change it now.
You generate sort of random name, you've generated a point to point connection to registration. You can manipulate it with data, you can generate it.
In the log of the controller, you have two important messages about the registration. DB filler task has successfully connected to the federator and is active and operational. And after the registration, we have the bulk. Two other important messages: current plan bulk has started and has ended, and jobs and workstation are now present inside the database.
Am I right in thinking that's best done when the system is fairly quiet? You don't really want to do that for the first time. I assume there's a performance hit for that.
Well, it's anyway related to the creation of a new plan, so it happens always after that. So you cannot really choose when to do it. It's related, it's connected to when you create a new plan, because at that point we need to refresh the data on the database.
Okay.
But it's being run, but that's being run by the user rather than directly from the controller. Once the plan starts, I think part of the work is the subtask taking that load.
Yeah.
Rather than the controller itself.
And it's running parallel with the plan. So it's not.
It's a
blocking the plan.
subtask into the controller address space, but it's not locking anything.
Right.
Will it impact the performance of the controller? Though even you've got another subtask within the controller running, even though it's not impacting or locking the current plan,
Consider
it's still
that
potentially could it impact the performance of the actual controller.
So it's, for example, in our test environment, to load the 200,000 operations, which is not a large number, but not so low as well. It takes a few minutes, like 5-6 minutes, and it's executing in parallel to the other activities. So even the impact on performance is limited in time.
Does it lock the database while it's doing this?
No. Oh, you mean the? I don't think so. No. You can, you mean the database that you want to access from the orchestration monitor?
So if somebody's outside of the database,
I think
set
you
time
use,
is
still
running.
use you see the old data until it's completely refreshed. You see the old data until it's refreshed.
Okay. Correct me if I'm wrong, but you will see the old data until it's completed, so the old plan, okay, you're doing the extension. And in any case, if you start to change some, you're still loading the plan, okay? But if you start to run some job or change some status, they will be sent in parallel way and you will see them directly also in the database. Because I think that is part of is after the presentation, but there's another task that will send all the changes as they happens to the database.
So it's one bulk update per day with the current plan extend, and then the rest of it is just
And all the rest of that
parallel incremental updates.
Let's extend not a replan,
Standard.
or it's extend and replan, or just extend
Yeah, and
and replan?
okay. You can access the data inside the DTB from the new orchestration monitor. In this case, the REST API is the query that goes directly on the database. So the flow follows start from dynamic workload console to federator and ends on the database. We can see a picture of the new orchestration monitor. In this interface, you have the three main objects, job stream, and workstation. You can see the data. You can also click on one of these data. You can perform action. You can also use the advanced query button to filter, for example, in this case, for the job stream, for job stream name, or by the status. And you can also change the number of objects that you can retrieve for each page. Okay, I want to highlight this slide because this is a new stuff, a new thing for the mirroring feature and for Z. We have the possibility to see also archived objects. So if you have objects that are in successful or cancelled status, at the next bulk, this object will be flagged as archived. And by default, these kind of objects are not shown in the new orchestration monitor, but you can change the filter as archived, and you can see the archived one. You can perform the action on archived object because they are not present in the current plan, but you have also a sort of historical archive of this object. The archived objects are stored in the database for a maximum time of 7 days, but you can change inside the fed variables.xml file this value in the mirroring.cleanup.interval keyword. You can specify a value from 1 to 7. After this time, all the archived data will be deleted on the database. Okay, from the new orchestration monitor, you can also perform action. In this case, you are not performing a query REST API, but other kind of REST API like get, put, fetch, and so on. The flow in this case starts with the dynamic workload console through federator, through Z connector, Z server started task, and Z controller. We can see also an example, putting a job in hold. So we are on ISPF panel. We have the job stream APPL test 1 and job PP. We can see that this job is in error status, but isn't hold. Okay. Now we can go on the new orchestration monitor. We can select the object. We can click on the old job button. And after a few seconds, we can see the status, successful status of the request. If we go back on the ISPF, we can see that now the job is in error, but is held. Another important event is the dynamic event. So in this case, every change that you have done on the current plan will be reflected on the database. The flow starts from the Z controller with the P filler through federator and ends on the database, and obviously on the new orchestration monitor. Also in this case, we can see an example changing a job stream priority. So we are on the new orchestration monitor, and we have a job stream, in this case the near demo job stream with priority 4. Now we can go on the ISPF panel and we can change the priority of this job stream from 4, for example, to 9. And after that, if we go back on the new orchestration monitor, we can refresh the page. And after a few seconds, we can see that now our job stream, that is the near demo job stream, has priority 9. Okay, now we can focus on the Swagger. So REST API version 2. We have 2 different points, the Z connector Swagger and federator Swagger. On the Z connector, you can reach the Swagger at this endpoint, HTTPS, EP and port of the dynamic workload console, and TWSD. On the Z connector, you can change and switch from REST API version 1 to REST API version 2, thanks to this section. This. And you will find the REST API of the 3 objects mentioned, so job, job stream, and workstation. On the federator, you will have a different endpoint to reach this worker, HTTPS, EP, and port of the dynamic workload console, TWSD, and Swagger UI. But in this case, we have a different kind of REST API because we want to have a unique point of control for all the engines. So you will find REST API that you can perform on Z, but also on different engines like the distributed engine. Yeah.
Sorry, there's something missing here.
Okay.
This is the first part of the federator. It's not all everything already done, but we will federate all the engines, so also distributed. Yeah. So currently is the plan, it's not already done, but at the end you would have a single view for all your controller and distributed environment as a plan in a single point. And you can mix the query and the option and the action from the single view on all the environment that you have. So the idea is to have that in WC, the single point control of your environment. And you can have a view for all the engine at the same time. Also the time zones that Cecilia told me before is because during the bulk, all the events are remapped to the UTC zone. Okay, so you can use the WC all the objects in the same time zone as you as user and not as environment, because probably you have or everything in a single country. But if you have different country, you will have also different time zone, and you have to have the data in a single point, in a single zone. Okay, in UTC, and after you can select and check what is your view of the time. So if I'm in London, I want to see what every date as Q1 as one day, but also if the job is starting in Guatemala or when it is on the road. This is only the first piece. We are missing some budget, some action, but at the end we will have, you already can consolidate multiple controller on the same federator. You can have multiple, the part of multiple controller in a single. It's missing currently.
And just to add one thing, we are also planning to implement the multi-engine views based on this. So you will have the possibility to merge data from multiple controllers, or in the future when the part will be developed also we used to have multi-engine views, but now they will be much more powerful in the future.
Okay. You can see an example of a query on the federated water. In this case, for Dublin plan. I want to highlight also a new way to filter for the query. In the REST API version 1, for the connector, we need to customize a JSON file to filter for the query. Now you can use the OQL, Object Query Language. These language has a simple syntax, so you have a field, operator, and value. I put a couple of examples. For example, to filter for job stream name that start with test 1, you should put inside the OQL field job stream name like test 1. Very simple. Or you can also combining different operator in or and, not in, so you can use different operator to filter in the query. It is more usable for the user. You need also to insert in the engine field the engine ID that you can retrieve in the federator engine connection resource. So you will retrieve the list of the engine that you have inside the database, and you can find in this section, in this case for one engine, the ID field. So you can copy and paste this string in the engine field. And after that, you have other optional parameter that you can customize, but after that you can execute the query. And after a few seconds, you have the response. In this case, we are retrieving 568 objects for Jardin plan. You have also the structure of the job, of the object. With the REST API version 2, we have also a new structure for the object. We can call it object version 2. They are more readable for the user. And you have also a curl command that you can put, for example, in a GCL or in a script to automate a process. So it is a suggestion from this worker. Just to sum up and conclude the presentation, I want to show you the advantages of the mirroring feature. Thanks to the mirroring, we have REST API version 2 and monitoring interface, and they can help us to handle large number of objects. The new monitoring is more efficient, user-friendly, and faster. Thanks to the query that will no longer be executed on the controller, we have also more performant GS task and controller. We built also an infrastructure to view aggregated data from multiple engines and in the future to perform query on multiple engines. And also the archived object that we have seen previously to have a sort of historical archive of what happened inside the plan in the past 7 days. Any comment on the core part of the new release?
This principally just to improve performance on the GWC.
Yeah.
One of the main points that we have seen we have a very good performance problem doing query on the controller. So you cannot scale much and open the access to the plan that want to be because it will overload the controller. In this way, you can offload this work to another piece. with a little amount of time during the plantation at the end of the day, okay? But it can scale better, and we can allow it also to open the plan for other people, and not only the files that people that usually use a form.
Yeah, the point is that this feature, in this we are moving to the second section of the presentation. Basically, we are opening the door for other new features. So this is a kind of prerequisite to evolve the way we can use the UI for Z. And I will explain this a little bit more. So here I have a list of features that will be considered as part of the next SPs on top of 10.2 for Z. But let me go for a while to the this one, okay, the last one, because the new federator and the support for these new REST APIs enables, for example, it's not actually here, but here we say complete orchestration monitoring. So right now there are a few limitations with the GA version delivered in 10.2 in December. But for example, we had in our list of requirements for a long time, like many years, the need for more complex filtering criteria in the monitoring views. So for now, as you know, we only support filters that can be used in end. So you can filter on multiple fields, but so the result will be just the end of all these fields. Let's say we are going to support complex monitoring rules through the new federator, because it will be impossible to do that accessing the data from the VISM files, as we would have basically to read all the plan to combine the filters and make available more complex and sophisticated ways to filtering for Z objects in the plan. So having the possibility to do that on the relational database where we store the mirroring data, it's a possibility to implement that. And that will come probably in next release or so. I mean, not next release on Z. One of the next releases on distributed, I think maybe the next one or the one after, we will implement complex monitoring filters, and that will enable that also for Z. That's an example, but there are other features like implementing also this kind of new REST APIs that we implemented for the plan with the mirroring, also for the database, will allow to support the new graphic modeling that you have seen before for Z. As well as another idea that we have is to enable the orchestration command line also for Z, so that you have the same command line that you can use with both engines. Obviously, we know that currently the syntax is aligned with the command and composer commands, but we are looking at the possibility to define aliases that are more in line with the usual commands on the Z side, so that you can use the same object, the same orchestration command line to talk with both engines seamlessly. And that's very important to unify, the way you interact with the products. So this federated mirroring is for now a kind of infrastructure enhancement, but it's to enable much more features in the future. We've been, waiting to modernize the mirroring also on the distributed side, but we started to implement it since it was not available at all on the Z side, and then the distributed will align with that. So, but let me go back to the list of features we plan to implement. on top of, so I already mentioned the enhancements on the cross dependencies. Is any of you using cross dependencies?
Yeah.
So the enhancements are on one side on usability. This should be the first to come to be delivered with an SPA. So right now there are not so many information when you try to display the shadow job, and we want to enhance that. And then the other, it's a larger one, it's to implement all the matching criteria also for cross dependencies. Right now we have only the closest preceding on Z for cross dependencies. So that's another important thing, because it prevents some scenarios in which customers can mix up the shadow job cross dependencies with different instances of the same job stream. So so you need a criteria like to search in a certain interval or in the same day. Otherwise, you run the risk to connect with the wrong instance. So that's something we need to do to make them more usable for the Z customers. That exchange, you have that feature for dynamic agents right now. So you have the possibility to pass variables between jobs on the same within dynamic agents, let's say. And we want to implement that also for decentric agents. So if you use decentric agents, we want to allow you to pass variables between jobs, which is quite convenient when you have maybe output from one job that you need to pass to the other one. So this is another feature we want to align with the distributed part. Okay, so this used to be called AI-infused scheduling. I changed the name, but basically this is a feature that the system is going to provide, or maybe I think it's going to be delivered this year on top of the ZOS system. It's an optimization of the workload execution on the mainframe provided by Just2. And it's based on the analysis of historical data of execution of the jobs. And based on the fact that through the scheduling product, you can identify the jobs that are periodically executed on the mainframe. So you can have you can enable the system to collect historic data execution for those jobs. So this is in conjunction with our feature where we will define for each job that you define in the database, for each operation that corresponds to a Z job, an identifier, a unique identifier, and we'll pass it to Just2 when we submit the job. By doing that, we enable the fact that Just2 can have control and historical information of execution. So the system is able to organize better the execution of the workloads, because we submit as soon as possible the job to the Just queue, and they know about the history of execution, so they know what resources are needed for that job, so they can optimize the execution. So this is a feature that could be quite important for optimization, and it's between Just2 and the scheduler, so our product. This originally the system Z was planning to use AI on the mainframe to support this, but for now it will be only based on internal Just2 algorithms, and perhaps it can be even I wouldn't say more efficient, but certainly will require less resources on the system. Then we have a requirement. There are many customers who are using workarounds to bypass the limitation of the number of the same occurrence that can be, which you can define in one plan, because it's based on the time, it's in the key, and that's in minutes. So if you have like ETT processing very often added to the plan, you have the problem, and many customers change the name of the job stream to bypass that, let's say. And they asked us to provide a field to save the origin job stream name, so that they can, recollect, associate the different instances. We have the possibility to support new metrics for the AI data advisor, but that would connect this feature to the workload service assurance. But this is also based on how we see the implementation of this component in our customers. If nobody will use it, we may defer this requirement, the implementation of this, to a later release. We want to complete the samples that we provide for the exit in Metal C. So that's for customers who don't have any more assembler skills, and they want to, use our standard exits, but using a Metal C code instead of assembler. It uses the same conventions as assembler, so basically we don't need to change the exits. We just need to provide samples to use them using Metal C, and we already delivered a few of these. We are going to complete the list of all the exits that we have. So this is also to enable modernization. And
just before you move on,
yeah,
I just had a question about how can you moved away from using AI for the critical jobs? Because 6 months ago that was like one of the main talking points for.
It's not us. It's this was always based on a feature that the system, the ZOS system, is providing, because they have introduced AI on the mainframe.
Yeah.
Native. But for now, they decided to not use AI for this feature, and I don't know exactly why. So this should be a question for IBM.
So, like, in terms of using internal algorithms rather than AI, does that limit the amount of efficiency it can produce? Because AI surely means longer it's on it, the more efficient it gets. Whereas an algorithm is a set algorithm.
I'm not sure. We should talk about it with the just two people, because they know what they are doing exactly.
Yeah.
They are supporting that feature, but I hope that by when we will deliver this integration, let's say, we will have also more information from them on how their deterministic algorithm works.
Yeah.
I still believe that there is space for a lot of optimization even without using AI.
Yeah.
And
a good
the AI part is interesting, but it's also requiring a lot of resources.
Yeah.
But I don't know exactly why they changed the approach.
Okay.
So I can.
Is there a particular version of Zoster that's compatible with a certain level?
I think it will be compatible also with the last ZOS release.
We're just releasing 3.1.
Yeah. There's a new one coming. I'm not sure if this year or next year. I think no. It will be in 2025, and for certain they will have this new feature. But I think they will implement it also on top of the previous.
So it would work with 3.1.
Yeah.
Okay. Thank you.
But as you understand, it being based on a system functionality, I don't have yet all the information. So I'm in touch with the just two people, and I will provide more when we actually implement.
Okay. Thank you.
Right. Thanks.
What else? So the first one here is a requirement coming from another customer. They want the support for the gateway on the central agents. Basically, to support also the NAP, there is a network, basically a network feature that could be available with FTAs, and it's not available yet with the centric agents. So we need to support it to allow them move off FTAs. And also, I think that the implementation of the gateway for this application may remove the need in the future for installing the dynamic domain manager in the middle when you install these agents, for example, on the cloud, manage cloud workloads. Nowadays, since the communication between the decentralized controller is double way, it's more complex to set up on a cloud external environment because of firewalls and so on. While the standard dynamic agents with the gateway, there is only one-way communication. So we will support something similar also on this entry. And I guess, okay, so what's your feedback about the idea of having the orchestration command line extended also to Z commands? Would you think that it's convenient to have the orchestration command line, downloaded on your personal computer and be able to issue commands to the product, like you do with with WAPL or other tools?
I think from a bank area,
It would be good, just
Of
about
course, you need to be
security, yeah.
surprised. I mean, it's not for everybody.
Yeah, I mean, as Jonathan said, security issues would come into it. I mean,
Okay.
in
But-
principle, yeah, it would be good to have a common interface between D and Z using the same language, but
For example, you could restrict even also the access just to the database for extracting definitions in JSON format, and then change whatever you need and then report it. It's not necessarily the way you work with the plan. So there are many possibilities, let's say, but
be very useful for that scheduling.
I was just about to say, John,
It would be great guns to be able to on both engines in a single approach, just like obviously cross-skilling a staff and workload sharing and stuff like that. I think it would be really useful to be able to do it on both.
okay. So this is kind of what we will be doing for the next couple of years. Anything that you see missing important, or any other requirement specifically for Z?
be interesting to see the extended information that you're providing for the shadow jobs. So if you
Okay.
could demo that at one of the next user
Yeah.
groups, that would be great for us to see.
Yeah, I think that we are not, discussing now the plan for next delivery in March. Could be part of that.
Yeah.
So possibly we will talk about it in the transparent development sections beginning of next year, and we can obviously talk about it in the next delivery.
We've been using shadows for a couple of years now, but our usage in the last couple of weeks, isn't it, John? It's gone up through the roof because a particular project has gone in. So it's become more to the fore. So seeing if there's more information behind that
If you are willing to also to join a call where we review the design of the announcement, we can involve you.
yeah, okay.
This is for you, Cecilia.
So when we do this announcement for the usability, probably at the beginning will be mostly for ISPF, and then it will be extended to the DWC. Could be that we deliver it in 2 steps, first for ISPF and then the following release also for DWC, but we can have a call, to discuss the design.
Nothing wrong with ISPF. Much prefer it.
Okay.
I applied the decision.
Really, that was more good.
Okay. Thank you.